this is the marking of the Making Salts exam. Make sure that you have your green pen and your blue pen ready so we can mark and make annotations. So the first question says, complete the table by writing the name and the formula of the salt for each reaction. The first one's been done for you. So here you have acids and alkalis, and this makes a salt. So the acid here is hydrochloric acid, and we can write the formula next to it as HCl. We have sodium hydroxide, NaOH, and this makes the salt sodium chloride. And to name the salt, you take the metal from the alkali, and also to name the end part of the salt, it's from the acid used to make it. So in this case, because it was from hydrochloric acid, it becomes chloride. So this part is from the acid. And our formula of our salt is NaCl. Next one, nitric acid, you should know the formula, is HNO3. And again with sodium hydroxide, we're naming the salt now, and so we have the first bit from the metal, which is sodium, and nitric acid has used to make the salt, therefore it is nitrate. The formula, sodium is Na, and the nitrate part is this bit here, and so it's NaNO3, so NaNO3. Finally, sulfuric acid, again you should know your formulas for this, is H2SO4 with potassium hydroxide now, so this is KOH, and the salt that we have formed is potassium, because that comes from, the first part comes from the metal, and the second part is sulfate, because it's from the sulfuric acid. The formula is K2SO4. Now I can presume some of you just wrote KSO4, but you can work that out. So we have K and we have SO4. Remember, compounds have no overall charge, so therefore the K, we know potassium is in group 1 and therefore has a charge of +1. SO4 has a charge of 2-, and so 2-. There we are. So the 4 charges to cancel out, we need 2 of the potassium, so the charges cancel out and the compound has an overall neutral charge, hence why it's K2SO4. Okay, next, acids can be neutralized by bases. The general word equation for acids being neutralized bases, acid plus base produces salt plus water. Remember, this is a neutralization equation. We have hydrochloric acid being neutralized by sodium hydroxide. Hydrochloric acid is our acid here, and sodium hydroxide is our alkali. Alkali because it is a soluble base. Write the word equation for this reaction, and here we are. We have the acid, hydrochloric acid, plus base, which is a sodium hydroxide, or an alkali in this case, produces salt. Remember, the first part comes from the metal, and the second part comes from the name of the acid, plus water. The next question asks to write a balanced equation for this reaction. So if I bring this down, we can see we have hydrochloric acid, so that's HCl, plus sodium hydroxide, NaOH. Anything with hydroxide, the ending for hydroxide is OH, and that changes into NaCl for sodium chloride plus water is H2O. Now notice it's asked for a balanced chemical equation, so a quick check to check that it's balanced. We have 2 hydrogens, one here and one here, 1 chlorine, 1 sodium and 1 oxygen. Let's check on the other side. We have 2 hydrogens, 1 chlorine, 1 sodium and 1 oxygen. Yep, it is balanced. Moving on, we have to tick one box to show which of these reactions will produce salt plus water and carbon dioxide. So the key bit here is what also produces carbon dioxide as well. And there's only one reaction here that produces carbon dioxide as a product, and that is acid plus metal carbonate. Next question here. So when copper oxide is added to dilute sulfuric acid, a reaction occurs to produce two products. Remember, this is our acid, and it's good to annotate this is our base. So the equation is here, and you'll remember this is the actual experiment that you did to make crystals. You added sulfuric acid and copper oxide to make beautiful blue copper sulfate crystals. Now I'll come back to that later. So this is the equation, and the question next says you are ticking one box to show how many atoms are there in the formula H2SO4. Well, I've written it out larger here, so we see 2 hydrogens, that's 2, plus 1 sulfur, that's 3, and plus 4 oxygen. So 3, 4, 5, 6, 7. So there are 7 in total atoms in H2SO4. We have to name the salt produced, and the salt produced is this one right here. If we break it up, we have copper, and this part is the sulfate. So the name of this is copper sulfate. Or to work that out, you take the first bit of the metal, which is copper, and because the acid is sulfuric acid, it makes a sulfate. Okay, Sarah used this method to make salt. Now you in year 10 have already done this experiment, and you should remember this. In this experiment, you heated up, here we are, you heated up sulfuric acid in the beaker, and you added spatulas of copper oxide to that sulfuric acid. And in each pair, someone was stirring till the copper oxide disappeared, and it was a blue mixture, and you kept stirring until that copper oxide disappeared. You kept adding a spatula of copper oxide, and you kept stirring until the mixture was no longer blue. This we call copper oxide was in excess. Finally, you folded up your filter paper into a funnel, and you poured that mixture into the filter paper, funnel, and also into the conical flask, so that the excess copper oxide remained in the filter paper, whereas the filtrate was dissolved copper sulfate. And then you poured it into an evaporating basin so that the water could be evaporated. Now this is a required practical, so please make sure that you know what happens at each step. And this is what Sarah used, the same method that we did to make her salt. So let's have a read then. So before copper oxide was added in to dilute sulfuric acid, why was it heated with a Bunsen burner? Well, we wanted to increase the rate of reaction. Secondly, how would Sarah know that the copper oxide was in excess? Well, remember, you kept adding the copper oxide, and you kept stirring. You knew it was in excess when the copper oxide completely stopped disappearing. In other words, you could say that there is black copper oxide left. Let me continue on. Why is the mixture filtered? Remember, we had to filter the mixture because you had this excess copper oxide in the beaker. So we're removing the excess copper oxide. And finally, you left it to evaporate because this copper sulfate was had water. So it was aqueous copper sulfate, and so we had to remove the water. So the substance room is stage 3. We had to remove the water to get the copper sulfate crystals at the end. Question 4. Calcium chloride is a soluble salt. It means it can dissolve in water. Calcium chloride can be made by diluting by reacting dilute hydrochloric acid with either calcium oxide or calcium carbonate. So let's put the formulae up. So HCl, calcium oxide CaO, and calcium carbonate CO, which is calcium, and carbonate, the carbonate part, is CCO3. What type of reaction takes place when an acid reacts with calcium oxide? Now, calcium oxide, remember, is a base, and acid plus base, this type of reaction is neutralization. You then ask to balance this equation of hydrochloric acid reacting with calcium oxide, and it has given here that note that some multipliers may be left blank. So here are all my atoms written out. So we have 1 hydrogen, 1 chlorine, 1 calcium, 1 oxygen, and in the product side we have 2 hydrogens here, 2 chlorines, 1 calcium, and 1 oxygen. So we can see that on the reactant side we are missing a hydrogen and a chlorine. So put a big 2 in front of it. So now there are 2 hydrogens and 2 chlorines. That is now balanced on both sides. Okay, continuing on with the questions. Jake added solid calcium oxide to dilute hydrochloric acid in a beaker. He also added calcium carbonate to dilute hydrochloric acid in the beaker. So the only reactant that's changed, we have oxide, calcium oxide, and we have calcium carbonate as well. So I have written here the 2 equations, and we continue on with the product. So remember the salt, we have a base, acid plus base, and that makes a salt, which takes the first part, calcium, and the second part, which is from the acid, so hydrochloric, will become chloride. And because it's a neutralization reaction, it produces water. Again, we have an acid plus base, but this time it's a carbonate. We still produce a salt, so we take the first half, which is calcium, and the second half, which is from the acid, calcium chloride. This produces water, but in this case it also, because it's a carbonate, it also produces carbon dioxide. So the question is asking, what is one difference between the 2 reactions the student will see? So you will not get the mark if you just said that the calcium carbonate, there is carbon dioxide produced. I won't give you a mark because this is what you observe, what you see. And therefore what you would see is fizzing. Now in the mark scheme it allows bubbles or a gas produced, but you need to be something, it needs to be something that you can see. Next, describe how the crystals of calcium chloride can be made with calcium carbonate and dilute hydrochloric acid. Essentially, this is the same method that you used in your making copper sulfate crystals. It's the same method in making these crystals, but instead you are using a completely different acid. So you still have an acid here, which is hydrochloric acid, and your base this time is calcium carbonate. So the first thing you do, remember when you first did this, you heated up the acid, and that's what you do first. You are heating up the dilute hydrochloric acid. Then after heating it up, remember you are adding excess of the base, and here we're adding excess calcium carbonate. Then after you added excess and you stirred, you filtered, because you had to remove that excess base. So here we are, you filter to remove the excess calcium carbonate. After that, you left it to evaporate. Remember this, evaporating. And then finally, you evaporate till crystals form, and these crystals are the calcium chloride crystals. Question 5. James produces zinc iodide. And there was a mistake here. The 2 should be a subscript 2 for zinc iodide, and this was his method. He weighed 0.5 grams of iodine. He dissolved the iodine in ethanol, added excess zinc, stirred the mixture until there's no further change, and filtered off the excess zinc to evaporate the ethanol. Now this is not an acid plus base neutralization reaction. We have iodine and we also have zinc, and here is, and then there will be equation in the next page. But now it first asks you, ethanol is flammable. This means that it can be easily set on fire. So what can James do to carry out step 6 safely? He doesn't want to be using a Bunsen burner because it can be set on fire. So instead, he should heat with a water bath. And there's no naked flames when you're using a water bath. Next, why is James adding excess zinc instead of excess iodine? So you're thinking to yourself, and this should be able to help you in this method here. He's adding excess zinc rather than excess iodine because, firstly, so that all the iodine reacts. Secondly, so the excess iodine remains in the solution so that, third mark, he can filter it off. And again, same method as this here. Okay, final question here is to calculate the minimum mass of zinc that needs to be added to 0.5 grams of iodine so the iodine fully reacts. Now, you've done this method quite a few times now, so I hope a lot of you are getting 4 marks. So it gives you the equation and it gives you the relative atomic masses. So the first thing is to write out the equation again. Zinc plus iodine produces zinc iodide. And you are adding the masses. So it says to calculate the minimum mass of zinc. So that is what we're looking for. So we put a question mark and grams. And here, this is what you've added it to, 0.5 grams of iodine. 0.5 grams of iodine. We're not bothered and we're not interested in the zinc iodide here, so we can leave that out. Mole ratios, we're looking at if there are any numbers in front. There aren't any, so we put 1 to 1. Firstly, we are going to work out the moles for the iodine. So we write out our quantities on the side: moles, mass, and MR. Moles, question mark moles, because we do not know that. Remember, we're using this one. So the mass is 0.5 grams. And the MR, kindly, is given to us in the question. Now, because it's I2, it's diatomic. All halogens are diatomic. We have to do 127 times by 2. And so our answer there is 254. We can enter that into our equation. So if N equals M over MR, which equals 0.5 divided by 254, and you do it on the calculator, it's 0.00197 moles, and that's the 3 significant figures there. So far, if you have figured out the MR of I2, that gives you 1 mark, and if you figured out the moles there, that gives you another mark there. That's the first 2 marks. Okay, so the mole ratio again is 1 to 1. Therefore, if there are 0.00197 moles of our iodine, there are therefore 0.00197 moles of the zinc. So now we're finding the mass of the zinc here. We write out our quantities. Now, moles we've just written down, 0.00197 moles. The mass, that's what we're looking for, question mark grams. And the MR, again, the question has given this to us, and that is 65. We add these numbers into our equation. So 0.00197 equals mass over 65. And then what we can do to get mass by itself, we times both sides by 65. These two cancel out. And our final answer, when you put this in the calculator, is 0.128 grams. 0.128 grams. The third mark comes from entering these numbers in the correct formula here, and the final mark is for your answer.